Hey everyone, and welcome. Today we're going to break down a brilliant little shortcut in statistics. It's a technique that just completely takes the headache out of calculating averages, especially when you're dealing with huge piles of data. It makes everything faster, easier, and honestly, a lot less scary.
You've been there, right? You're staring at this massive table of numbers. You're trying to add them all up, multiply things out, and it's so easy to make one tiny mistake that throws the whole thing off. Well, what if I told you there's a much more elegant way to handle it?
All right, so let's dive into a real-world example to see what I mean. Imagine we need to find the average monthly water consumption for a neighborhood of 70 families. Now, the data we have is all grouped together in these ranges. So this is what's known as grouped data. And the standard way to find the average here, the sort of brute force method, is to first find a single value to represent each group. We do that by just finding the midpoint or the mid-value for each of those intervals. Okay, so the next step is to multiply that mid-value by the frequency. How many families are in each group? And you see what's happening, right? The numbers in that last column are getting pretty big, pretty fast. This is exactly where simple calculation mistakes can sneak in. And finally, you have to add up all of those big numbers, which gives us 1,489, and then divide that by the total number of families, 70. Now, you can totally do this, but it's tedious, isn't it? And the chance of making a little error is pretty high. There has got to be a better way. And you know what? There absolutely is. The secret is to completely change how we look at the problem. Instead of wrestling with those big, clunky mid-values, what if we just made a smart guess for the average, and then just adjusted it a little bit at the end? This guess has a name. It's called the assumed mean. Think of it like dropping a convenient anchor point right in the middle of your data. A really good strategy is to pick the mid-value of the group with the highest frequency. For our data, that's the 21 to 23 group, so let's make our assumed mean, our guess, 22. So once we have our guess, we calculate something called deviation. And don't let the name fool you, it's super simple. It's just how far off each mid-value is from our guess. This simple little subtraction is the secret sauce that transforms our big number problem into a smaller number problem. And the real beauty of this method is that it's just a simple, clear procedure. It's not complicated at all. Let's just walk through the steps really quick. Okay, so first, we make our guess, our assumed mean. Second, we find that deviation for every single class. Third, we multiply that nice small deviation number by the frequency. Fourth, we add all those results up. And finally, step 5, we use a really simple formula to adjust our original guess. Let's see it in action.
Okay, and now for the really satisfying part. Let's apply this amazing shortcut back to our water consumption data. Seriously, prepare to see the magic happen.
And there it is. I mean, just look at that. Instead of those huge numbers, look at what we're working with in those last two columns. They're tiny. We've got negatives, positives, even a 0 right in the middle. Multiplying and adding these up is going to be a piece of cake. Let's just put them side by side for a second. With the direct method, we were forced to add up all these big clunky numbers to get 1,489. With our new shortcut, we just add a few small positive and negative numbers together to get negative 51. The difference is just, it's night and day. So, the big question is, what do we do with this much simpler number, negative 51? How does that little number get us to the final correct answer? Well, it all comes down to one wonderfully elegant little formula.
And here's the formula. The actual mean is just your assumed mean, plus the average of all those deviations. It's so intuitive when you think about it. We're just taking our initial guess and then correcting it based on the average error we found across all our data.
So we just plug in our numbers. We take our guess of 22, and we add our sum of deviations, which was negative 51, divided by the total frequency, 70. That gives us 22 minus about 0.73, which equals 21.27. The exact same answer as that brute force method. But wow, that was so much less effort. So really, that's the whole idea here. The assumed mean method is all about working smarter, not harder. It's a fantastic tool that makes data analysis feel more intuitive by just transforming a potentially messy, big number problem into a simple, small number one. And that kind of leaves us with a final thought, doesn't it? This whole idea of making an educated guess and then just systematically adjusting it, that's not just for statistics. So think about it. Where else in your life, maybe it's your budget, planning a project, or even cooking, where could a guess and adjust strategy help make something complex a whole lot simpler? Thanks for tuning in.